Hello, Debian conference stuff. Welcome to Cédric Villemain from Data Bene, who is going to talk to us about Postgres. Thank you.
Thank you, Pierre. Bonjour à tous. Hello, everybody. So, yes, I'm going to talk about PostgreSQL and container groups. And cgroups down the road. So I'm Cédric Villemain. I'm active on the PostgreSQL community for more or less 20 years. And I started with some core committers 20 years back. And it helped me move forward into PostgreSQL. And I was not a database guy at all at the beginning, more developer operation. But with Postgres, I got good code, good mathematics, good development, and good operation. So, all in one. Perfect. I co-founded Second Quant in France. For memory, Second Quant was a major contributor of PostgreSQL, and which has been rebranded to Data Bene 3 years ago. So, Data Bene is a company providing PostgreSQL services, training, and everything. So, the agenda for today is a little bit long. The idea is to look at PostgreSQL and what we can do with it and with cgroup. Can we use cgroup in PostgreSQL? Does it make sense? And how to do it? It's my third Debian conference, also my first mini-debconf. I didn't know such a level from the audience, and when I look at the schedule yesterday evening, I say, wow, okay, I'm between kernel developers and kernel developers. So I have a question for you, or you'll have information from me later, and I will appreciate some feedback. So PostgreSQL is an old, very old community and project, older than Debian. It's back from the 86, because Stonebreaker did it this long time ago, just after Ingress, Postgres. So this is a BSD-like license. And there is also a very strong and global community on PostgreSQL, not as large as Debian, but very nice too. Very open, and very the same kind of community where it's not owned by companies. This is only community project. So, some of you don't know PostgreSQL yet? No? Okay. So, well, you already know that, probably, that PostgreSQL for this last year is just worked on Stack Overflow, but it may be like 10 years that year after year PostgreSQL is growing, increasing in developer, in companies, and everywhere. Still, we have a lot of development in PostgreSQL, and there is also a lot of feature pending that we do not have yet. And so, this is a little bit what we are talking about today. So PostgreSQL today provide C code. This is mostly only C. There is some kind of Perl inside and minor things, Python, etc. But the main component is C language. And it's C in 99. We have just-in-time compilation in terms of optimization. So PostgreSQL has also in LLVM, so we can compile some code on the fly to optimize some processing inside PostgreSQL, which is also very good news and useful. Not perfect, still increasing. It was also the occasion for the PostgreSQL community to get back to LLVM and to provide some fixes and improvement in order to make LLVM work for us. Since some years, we have a couple of, maybe more than a couple of SIMD instructions. So SIMD instruction means that we are going to provide not a single value to check in a session or whatever, but a range, a group of values to check all together at the same time. So it's much faster vectorization on the CPU. A very important point, PostgreSQL has no thread. So it's only forks. Fork and fork. No thread, never. There are ideas for maybe 5-8 years to try to get thread into PostgreSQL, which is like a good idea, and colleague Eiki Nakangas is working on that a lot, but it's very huge task, and a lot of core committers and people from the core team are really against this move because this is very dangerous move for a database like PostgreSQL. There is a lot of risk to break something, and to break something that we discover much later. Also, and it's important for the later with the cgroup, we have shared memories in PostgreSQL. It means that when we start PostgreSQL, the main process, Postmaster, is going to acquire shared memory and to use this shared memory and to manage that with this processing. It's very convenient for database system, but for container group, we will see that maybe this is a problem. And also, we are sharing a lot of files. It means that in PostgreSQL, when you write something to a file, some files are managed just by a single process. But more often, when you're writing to files with PostgreSQL, this is from distinct processes, from backend, from the main PID, or from maintenance task, or whatever. So it's just an export from Wikibooks, which outline more or less what we have in PostgreSQL. So what will be of interest for us today is all those rectangles, the blue one here, logger, auto vacuum, backend processes, collectors, checkpointer, background writer, whatever. Every rectangle in blue is a backend type in PostgreSQL. It's a distinct process, a distinct fork, maybe more than one fork. For example, in auto vacuum, we can have more than one. All those backends have distinct activity to do in a database. They do serve the queries. They do some background processing for user request. They do some background writing to do the wall. The wall is a write-ahead log. It's like in a file system. You have metadata and data. PostgreSQL is also an IC system, like a file system, so we need to be compliant and ensure that we can recover in case of crash. Also, our metadata journal is called wall. So the wall here, very important. And as you can see, it's a little bit complex, and we have a lot of arrows between racing, because more or less, most of the process are able to access shared memory, and most of the process are able to access any file. Okay? This is the root idea for us today. This is for curiosity. If you want to go on the PostgreSQL.org website, there is some developer section where you have a nice diagram, which is not the same as the previous one, but where you can click on pictures and go directly to the doc and to the code where we explain what is going on. So the idea is that we don't have cgroup in PostgreSQL except the main big one, as we used to have with systemd. And so I was looking at solutions to change that, okay? And so not my first idea, but first idea from cgroup is to do cgroup 1, which was hierarchical cgroup, but also based on controllers. It means that you have a tree based on memory, and a tree based on the CPU, and a tree based on I/O, and maybe another tree for IRQ or whatever. But I believe there were only 3. This has changed, but it allows already to get better monitoring, limit memory and CPU, whatever we know with container group. Someone does not know really container group. Do I need to expand time on that, or? Okay. So we had a lot of information with this container group V1, and please remember this point about memory and CPU, which were really like distinct units in the cgroup V1. Oppositely, in cgroup V2, we changed a little bit of that, because instead of getting a tree or a parent which is based on memory, CPU, or I/O, we're going to use hierarchy of cgroup. And in each cgroup, you can have distinct controllers, one for I/O, one for memory, one for CPU, and so on. Okay? So this single called unified hierarchy of cgroup is really the modern way, the new way to do that. It's also safer. It's safer in some way because it's easier to share a group and to push a group forward. For example, if you're using Docker on a machine, Docker will just manage his own container group inside, and he get delegation, so he move his own group out of the tree, and so there is no conflict, and he can manage himself or itself his own container. There is two main points which I was targeting about cgroup with PostgreSQL. First one is about to get PSI, which is procedure style information, which is a feedback from the system, from the kernel, about what is going on, about whatever controller you have defined. Okay, so it means that in a kernel we have distinct controller defined to do I/O, and so we can detect if there is I/O stall, for example. Are we waiting from one process or more than one process for more than 100 seconds, for more than that many milliseconds? Okay. The procedure style information is very interesting component. You are aware of what's going on, sure, but you have also other metrics. It's a little bit more precise because the update of the procedure is very a short time instead, for example, of the load average, which is very slow to update. And the other point which was of interest for me was the cgroup BPF, which means a way to maybe more easily be able to attach some BPF code on a production machine where we need to debug, maybe the maintenance, maybe a backend, or whatever. We used to do that via just assigning with the PID, but getting a cgroup BPF and getting cgroup inside PostgreSQL may help us providing BPF directly for a full cgroup, and maybe do more than just debugging. So here's the comparison between the previous one, which is aligned with the memory and CPU, and the current one, where in each group you're going to manage memory, CPU, and I/O all together. Well, not exactly all together, but in the same cgroup. As you can see, I have some content which came from Meta, so from Facebook. It happens that Facebook has been very active in this domain. I'm not sure, but I believe they did most of the code for PSI, at least the V2. And also it means that, for example, for the I/O layer, it works with XT4 and XFS and stuff like that. But for example, the I/O latency does not work with those file systems. As far as I know, latency works only with BTRFS, which is a file system from Facebook. And in fact, they did a lot for BTRFS, but not for other things. So there is maybe pending action in this area. So what the cgroup use case are? By default, this is on systemd. So if you're running Debian today and the default one, you have systemd installed, it means that you always have a very large tree of cgroup managed by systemd for each new process. Not exactly each new process, but you start the system, you have a slice user, system slice, you start your user session, inside user session you have your own process, and so on. So you have a full tree managed by systemd, where you can, via systemd unit, scope, and slice file, define what are the resources load or that you want to protect. But cgroup are really often are just the ground of Docker, Kubernetes, not sure about background, and Podman. So it means that Podman, Docker, for example, are just framework on top of container group. It's a little bit short, but it's a way to see that. So the idea is to get that in PostgreSQL. Really. The idea is to get a fully integrated support because, as I said, in PostgreSQL we do forks. We do a lot of forks. And so it's not convenient from outside of PostgreSQL to attach PID to new cgroup. And if you don't do that on PostgreSQL source code, on core, you need to do that after that, because in PostgreSQL we can have plugin extensions where we can load shared object. And so we can reassign the PID later in the workflow. But also with cgroup, the sooner you do that, it's the better. So instead of doing that in an extension, I did that in PostgreSQL just to have a playground and be able to run benchmark. And okay, so this example, I had to switch from my usual slice to Beamer back, and the rendering is not very good. So This is currently what we have, which is maybe easier to see if we do that. One second. Okay, so currently you have that with systemd on your laptop or whatever. I have all those things running. So you see at the top there is a slice, user slice, under a big main C group. And if I go at the bottom, somewhere here, there is a lot of things. Okay, and then we have init scope and system slice. And so for some services it's system slice, some other services are in user group. Okay. This is the default setup from systemd. What is very nice for me with systemd in this context that everything is already set up. And if you look on the internet, you have a lot of information about on you need to create new directories to see hash on to your user or do whatever you want. The true story is that you need to go on your systemd unit and you just append delegate equal yes to your service unit and blam. You can manage your own group from your unit inside your own process. Because when you do that, you inform systemd that you're going to manage your C group and you're going to move it away. And systemd will stop trying to manage your C group internally. Okay? So because you cannot be two managers managing C group at the same time. It's systemd or it's you. So really this point was really convenient. Okay? I don't have the slide for that, but the solution also works on Docker and on Podman and everything. So on Podman we do not use systemd, we have an alternative way to do that. But on main system we just one line and it's done. So I got inspired by the Facebook work on FTABX, which is FBTX, FBTax, I don't know how they call that, which is like a project to be able to maintain a good load average on the machine, optimize the resource, and prevent stall, and prevent fork bomb, and prevent a lot of things for their own management. Inspired by that, I said, okay, let's do something similar in PostgreSQL because we have same needs. We have some very critical system, we have maintenance tasks, we have auxiliary tasks, and backends. So let's organize and start from that. So the idea here is that on PostgreSQL we are going to, thanks to the delegate equal yes, you're going to be able to create our own C group on a root, or on the system slice, and do whatever we want in it. Okay? And then we need to push each fork on its C group. So as I said, I do it in core because it was easier, and also as I wanted to do benchmark to be able to evaluate performances of the solution, I wanted to do something near the core to be sure that we're going to migrate PID as soon as possible. So this choice for C group v2 because it's more modern, there's systemd, and it works with and without systemd. It's super easy to set up. And the alternative design, I mean, when I'm saying I do like this, it means that I'm going to just echo two files, create layers and all inside my process. So I manage C group with a file system, whereas the default today and the recommended way to manage that is to use system SDBus. So it's more convenient. But if you do that and you are inside the Docker, for example, you need to mount stuff from the host or whatever. Well, it's not an area I know a lot. And apparently it looks like more complex, more dependencies also in my code and in the Docker environment. So I choose all way to do things. So I decided to create 4 slices for the PostgreSQL. One for the critical process, which is more or less what we're going to push, the postmaster. Postmaster is the main process of PostgreSQL. This is the first one you start. And every time you create a new backend, it is created from the postmaster. So I put it in a critical section, assuming that if this one is dying, everything else is dead. So this is probably the most critical process in PostgreSQL. And then I put a maintenance one, which is, as said, for the maintenance, and workload for the workload, auxiliary for the logger. From PostgreSQL, we have what we call GUC, Grant Unified Configuration. This is parameters for the configuration of Postgres. So what I did is that I added new parameters inside PostgreSQL, so I'm able to enable or disable cgroup with just a restart here. And I'm able to just, with a reload, change the controller. So I can define this controller going to look at the I/O memory and CPU, and the other one, I do not want to look at the memory. I do not want to control memory because it costs me too much, for example, or whatever. So I provide user-side simple API to be able to just change how you manage the cgroup. And here the controller. The controller we are mentioning here is about the PSI. And this is, I believe it's a complete list. Yes. This is a list of backend types we have in PostgreSQL. So there is not just one or two, okay? Some of them are very like, World Summarizer is pretty new. It's from PostgreSQL 17. It allows you to get incremental snapshots. So it means that today in PostgreSQL, when you do a new snapshot of the full machine, of the full database, instead of snapshotting everything, it's going to just extract the good pages that it needs and require to do the snapshot. So this is not very intensive, and we can kill it. It's not a problem. We have world writer. It's very important. This is a metadata journal. If it fails, PostgreSQL fails. Currently, if there's a panic in PostgreSQL, if you touch the world writer. However, well, it's like this. Maybe what we really want to know is that checkpointer and background writer are doing the same thing, not at the same moment. It's like it's like the write back in Linux. We have a shared memory with pages loaded, and they're going to be dirty, and we need to clean them in order to be able to put a checkpoint in the whole stream, in the whole files. So when we restart from this previous restart point, this previous checkpoint, and we do not have to replay years of history, okay? Like a journal. So the point that checkpointer is doing that on time basis, at maximum, for example, each 5 or 10 or 15 minutes, whatever, or after a certain amount of space disk you have consumed, or space memory you have consumed. Alternatively, the background writer is going to evaluate what the other backends, the queries, are doing, how far they consume the memory, and how far it's dirty, to ensure there is enough room in the future for next backend to get the queries without having to flush out the buffers. Okay? So checkpointer is time, and background writer is every time, like this. You know, they do the same thing, they do touch the same file, and they do touch the same memory. Backends are queries. And background workers are advanced backends for userland. Same thing, they do touch the same memory, the same files, and everything. And AutoVacuum workers and launchers. Launcher is a manager for AutoVacuum, which is a daemon to ensure that we keep clean the indexes and the heap, the tables of PostgreSQL. So I also added those kind of GUC for PostgreSQL. So for each kind of backend type, we can define in each in what slice you want to add it. Okay. So I just put some default, but you can create new slices and you can define new way to do things. All in all, it's not a very large patch, okay, honestly. I believe it's on 2 slides, yes. It's not a very large patch. The most room is used by the GUC, because defining new parameters in PostgreSQL is like wordy. And and was documentation. But other than that, it looks large on Postmaster because it's a quick patch. I just put a static inline functions and let's go. So here we are. But after all, not a very, very huge patch. So what it brings already, when you have that with PostgreSQL, it brings that. This is not good. If I go on PSQL, so it's on, but I'm going to alter it to put it off. Okay, so it's off, and if I do this, I have, as before, sorry, I'm going to do another one which is similar but more convenient. Okay. So this is what more or less what you have by default with the systemd setup. Here it's on our custom build, so it's not in the same tree, but this is what you have today when you run PostgreSQL. A big one group and everything in it. Okay? So it's already nice, and you can already see things like this, which is great. And even if you load something, like this, you see it's moving and consuming memory and input and output, but that's all that you can get, okay? We have other solutions. We have some agents to go deeply inside the processing. Inside PostgreSQL, we have pgstat.io, which is a very tracking by process, but it has a huge cost also, because it's doing get system before and after block and fetch requests. It's just, well, it depends of your system clock, it depends of external stuff. And so the point is that now I'm going to reactivate this. Okay. And so I do restart. No, sorry. So now I have more groups, you see, for each slices and for each kind of backend. And so if I start to now the same benchmark, it's going to move. So the idea really was to be able to get that, just out of the box, at minimum. So at least from an operation point of view, you can evaluate what's going on, even from the system without logging in PostgreSQL. Okay. So this is what I showed during in the terminal, okay? So far, so good. It's nice. You like it? You want to get it on your PostgreSQL boxes? But, so it's nice. It works also in Podman Docker. That's true, I tested. I didn't test in Kubernetes. I don't use Kubernetes myself. But it should be exactly the same thing. There is problem. There are problems. Oh, I talk too much. There is no by default in cgroup. You need to create things, new things, and define things every time. You cannot just inherit stuff. So I go faster. There is controller overhead. When you add a controller on I/O, memory, or CPU, it's going to consume resources. You don't want to get a controller for each and all cgroup in your machine. Else, probably you're going to consume more time managing your cgroup and analyzing your resources instead of just running processes. The big problem is that in cgroup, the cost is attached to the cgroup who touch a memory. So when I create a memory fragment and I use it when I instantiate this memory, even if it's another PID in another cgroup which use this memory, it will be accounted by my group. So there is a conflict, and maybe the group V1 allowed to really split that. And today with the group V2, there is fuzziness here, and it's not possible to know exactly who was consuming this memory. And we have the same problem with the write back. With cgroup V2, this is a cgroup which does the most I/O on an inode, which keeps the inode on its cgroup. So on a cgroup, you have, I believe this is a foreign page, and so at some point, if there is more foreign page than local pages, then the inode information are going to move to the other cgroup. Okay? So it means that in PostgreSQL, checkpointer, background writer, backends are going to work on the same files, on the same inodes. And possibly, depending on your workload, you're going to get movement between distinct containers just because at some point the checkpointer consumes all inode, all IO on the inode, then it's the backend, so you migrate back to the backend. And I don't know exactly the cost of that. I want to benchmark it and also look, maybe with kernel hackers, if there is something to do to manage to get a better view here. So, it's up to the admin. You can do benchmark, you can talk cgroup, you can plug any application with talk cgroup, and it will work. That's perfect. Okay. So I said more benchmark, because if it costs too much, it won't be valuable in PostgreSQL. A priori. For example, when you create a new fork, you need to migrate it maybe from this critical group to backend group, or you need to get the critical postmaster in the backend group, which makes no sense. Or maybe we can use that to just create new backends before they have connections, froze them, because with a group you can froze processes, and so we just need to unfroze when we have a connection. So maybe if there is a cost to set up, at the end, for a new user to connect, it will be faster. So maybe it makes sense. Even more if we are able to get this connection, incoming connection from a BPF, and so maybe from the BPF being able to restore PID and unfroze them. This is not done yet, it's just exploration. This is technical size in PostgreSQL. We have a wait event machinery which is on top of Pol, ePol, and the Windows Alien solution. And so I just patched PostgreSQL to be able to support Pol query, which allows to get pressure inside PostgreSQL, meaning that with this patch, we can get pressure event on AutoVacuum, on Postmaster, on Checkpointer, on Background Writer, whatever, and maybe do whatever you want with that. If you want to test it and have fun, there is a branch here with the patches for cgroup and the wait event of PostgreSQL, so you can use it, and some alternative documentation. And I believe I'm done. Yes. And maybe we have room for questions because I accelerate a lot.
We have 5 minutes for questions.
Cool.
And nobody wants to ask anything? Everything was clear for you?
Despite my accent? Maybe I can challenge you. I have a question. What about this stuff about the write back? Is it really something annoying? Is it really so costly to move the process between groups? Is it really so much a problem to get memory accounting on one cgroup despite it's consumed by another cgroup? And what is the long-term IDE on a kernel and on Linux? If you are aware of that, I'm really interested. Yes.
Sorry, I don't have an answer to your questions, but I do have a question. Is this something that you would see as a way to better control memory pressure in your database? I know that Postgres has a tendency to really dislike when one of the processes crashes and it uses some of the shared memory. And so is that something that can help or not?
Yeah, absolutely. That was one of the many points. Currently, because many processes are touching the shared memory, if there is a massive failure on a process, we're going to crash the process, and given we don't know what was the status with the shared memory, we're going to kill everything and restart. By using cgroup, we cannot really prevent that. But what we may be able to do is to use the cgroup feature, which is say, this cgroup is protected. It needs to get a minimum of memory, which is this level, meaning that for the cgroup management, given this cgroup has a minimum memory setup, and if we need to blast something, it's going to blast something outside of this cgroup until there is no alternative solution. Okay, so you're probably dead already. And this is one good thing first. Also, you can say, if you have to kill something, kill them all, please. So on cgroup, for example, when we are looking at backends, we can say, hey, you're going to kill a backend, kill them all. I'm going to do that anyway. At least you can do one at all, because this is the main risk in PostgreSQL, is to get postmaster crashing, other processes crashing, backend still active with the shared memory, doing transactions, and do not notifying that it's not going to work. And there was another point. Yeah, and the NUMA. Also, it can be used for NUMA and to segregate a little bit more. But the problem is that most of the processes are touching shared memory, so it's very hard to prevent that, except the war writer. War writer got memory on shared buffers and shared memory, but just for PostgreSQL 16, we improve the dynamic shared memories management in PostgreSQL, which means that today, for example, the war writer can be rewritten to not use shared memory but DSM, meaning that if it fails, we can kill it, even it's a bad idea, without restarting everything. But this is sick to do. And the number of processes where you are able to do that are very small.
Is there a chance to have it in Trixie or Forky?
Honestly, from PostgreSQL community point of view, if it goes in 18, it's a miracle. Okay, maybe it works, but benchmarks will be very required to be able to make sure that there is no side impact. Here, what I do is that I set up a global switch, so we can use it by default. It will be off and it should be no cost for no one. So I expect that maybe they will accept the patch, and so we can expect it in 18 or 19. But also it needs to make sense, because PostgreSQL project is very strong and does not use to do things because it's fancy or because people say, hey, look, it's a good idea, Cédric got it. Yeah, but... So I cannot grant. But maybe by patching on PostgreSQL, on Debian, I'll talk with Christophe.
Yeah. Yes, have you tried to use only cgroup for CPU, for example, not for memory, and just to limit the problem on memory, it seems?
Honestly, I didn't get that far yet. I did these patches and all, I just did some few quick benchmark, but I was more looking at getting a good structure to be able to then push forward, and maybe I'm going to some benchmark, but it's probably colleagues who are going to do that.
I asked because there is a list you showed in the configuration. You can say.
Pardon?
I asked because I saw you have a list. You use CPU memory for cgroups. There is a list. Yeah.
Yeah.
In a slide.
Yeah, it's very easy if you want to just try it. I mean, what I need to do that. You see. Wait.
Thank you. Thank you. Thank you very much. Yeah.
I show you there. Merci.